Hey everyone, we're going to use the principle of mathematical induction to prove that a plus b is a factor of a to the 2n plus 1 plus b to the 2n plus 1. Before we get started, just remember whatever number you put in here, this is going to be odd. So this is either going to be like 3, 5, 7. If you put in 1, it's going to go, this is going to be a cubed. You put in 2, this is going to be a to the 5th. So we're talking about odd powers here. All right, so let's get started. We're going to check first on condition 1. That is n equals 1. So what we're saying is a plus b is a factor of, and everywhere there's an n, I'm going to put 1. So this is going to be 2 plus 1. I'm just going to write it out because it's pretty easy. So this is a cubed plus b cubed. When you plug in 1, you get 2 times 1 plus 1. Now it's a factor because when you factor this, this is going to be a plus b, and this other factor is going to be a squared minus ab plus b squared. So clearly this is a factor of this because it's right here. So that means this divides this. All right, so that's what the whole thing means. Now, for our second part, for condition 2, we're going to say if a plus b is, I'm going to shorthand this a little bit, is factor of a to the 2k plus 1 for some k, b to the 2k plus 1, and we're talking about positive integers, then, so that's our assumption, then we're going to show that it's a factor of a, we're going to show that this is a factor of a to the 2k plus 1 plus 1 plus b to the 2k plus 1, k plus 1 plus 1. And this actually equals a to the 2k plus 3 plus b to the 2k plus 3. So I'm going to rewrite this as this equals a squared, and I'm looking at this part, a squared times a to the 2k plus 1 plus a squared times b to the 2k plus 1 minus a squared times b 2k plus 1 plus b to the 2k plus 3. All right, when you factor all this out and simplify, we want to make it look back to the original. So we want to get back to our squares and everything. So we're going to get back to a square times, we have two of these, a squared, so it's going to be a to the 2k plus 1 plus b to the 2k plus 1 and minus b to 2k plus 1 times a squared minus b squared. Now, I know that already that a minus, or a plus b is a factor of this. Okay, because we just showed that. That's our assumption. All right, and I also know that a plus b is a factor of a squared minus b squared, because this is a squared minus b squared is a minus b times a plus b. So there's your factor. So it's a factor of both pieces. We don't really care what those two equal. So that means conditions 1 and condition 2 are satisfied. So the statement is true. And that's it. Thank you. Have a nice day. Bye-bye.